2.5, complex zeros. And the fundamental theorem of algebra. And just checking this was a section y'all had notes for, right?
Yeah.
Okay. I know you pretty much had shown me them earlier. I just wanted to make sure before I continue, and then y'all are thoroughly confused because you don't have the notes for them. So, write the polynomial in standard form. Identify the zeros of the function and the x-intercepts. So, I've got f of x equals x plus 2 times x minus the square root of 3i and x plus the square root of 3i. So essentially, I'm foiling here. I have a difference of squares here, so I would do those first. And then I'll go back and do the zeros and stuff in a second. But to start out, I need to get it in standard form. So x plus 2, what happens when I multiply these together since they're a difference of squares?
Oh. You get rid of the middle term.
So what do I get then?
X squared minus.
Plus 3.
Yeah, so ultimately it will be, but it's minus 3i squared, which is going to be plus 3. It's fine if you write it that way, but I'm writing it out so we can see everything. And then I need to FOIL this, and what do I get when I do that?
X cubed.
Plus. Plus x squared. 2 x squared.
So I multiplied this times this and this times this, so now I need to do this times this, which
Plus
is
3x plus 6.
so that's now in standard form. So that's the first thing it wants. Then I want the zeros and the x-intercepts. So what I do is I set each piece of this equal to 0 and I solve. So I'm not even going to make you actually set them equal to 0 and solve it. I'm just going to have you tell me what they are. So if I were to set this first one equal to 0 and solve, what would I get the 0 to be?
-2.
What about this one?
3 or square root 3. 5.
Yep. And this one?
Square root 3, 5.
So those would be the zeros. And then x-intercepts would be where? Where does it cross the x-axis? What does a 0 mean?
That hits the when it's graphed.
That's where it crosses the x-axis, right? So what would my intercept be?
2.
X equals -2. The other two are not intercepts because these are what kind of numbers? Imaginary. Okay, so those would not be intercepts. The only ones that are going to be intercepts are real numbers. So that's all you would have to have for that one. The zeros, the intercepts, and then standard form. Okay, the next one is write a polynomial function of minimum degree in standard form with real coefficients whose zeros include those listed. So they're giving us zeros and we need to work to this function. So essentially they start us with this information and we're working to get here. So number 8, -4, 1 minus I, and 1 plus I. Now, I don't know if this was in your notes yet or not. If not, it'll come up later, but okay, yeah, it was. The complex conjugate zeros theorem. If 1 minus I is a 0, then 1 plus I also has to be. So sometimes they won't write them both. You just have to recognize that they both are there, okay? So if negative I is a 0, then positive I is a 0. But in this case, they already wrote both of them for us, so I don't have to do that again. So what degree is this function going to have? 3. It's degree 3. So this is x equals all of these things because they're zeros. So I need to rewrite them as factors. So that's going to be x plus 4. I'm moving all this stuff over. So x minus 1 plus I. And then this one is x minus 1 minus I. And then now I just need to multiply. So I would save the x plus 4 part for last and do the other stuff first just because I think it makes it easier. So multiply here, I would get x squared minus x minus ix or minus xi minus x plus 1 plus I plus xi minus I squared. So I just superfoiled that. So now I would go through and cancel things out. So I've got a minus xi and a plus xi, so I'd cancel those. I've got a plus I and a minus I would cancel those. How can I rewrite this negative I squared? Yep, so plus 1, so I'm just going to redo that. So then I can combine like terms to simplify it down. I'm going to have x plus 4 times x squared minus 2x plus 2. Now when I multiply, FOIL, whatever you want to say, all of this, what do I get when I do that?
X cubed minus 2x squared plus 2x plus 4x squared minus 8x plus 8.
Yep. And then just combine like terms. So I get x cubed plus 2x squared minus 6x plus 8. And that would be your function of degree 3. Does that make sense, what we're doing in these? Okay. I'm really only doing like one of each kind because the stuff that we're doing like continues to build, so you kind of end up doing the same thing over and over again, just in a different way. But if you need to see more, just tell me to stop and I'll do another one. So number 14, they still give us zeros. They want us to write the polynomial minimum degree in standard form with the real coefficients whose zeros and the multiplicities include those listed. Okay, so in this last one, everything we were assuming was a multiplicity of 1. They listed out all the zeros for us. So in 14, I've got -1, and it's a multiplicity of 3. And then I've got 3 with a multiplicity of 1. So based on what they've given me, what would my factors be if my zeros are -1 and 3?
Would be x plus 1 cubed, and then x minus 3.
Yep. So, and you already said it, but multiplicity of 3 means I take this factor and I raise it to the third power. Some people think that it means to multiply it, but it means to raise it to the power. So that just means I have a triple zero at -1, and I have a single zero at 3. So then I just need to essentially multiply this out. So this would be the same as x plus 1 times x plus 1 times x plus 1 times x minus 3. If I multiply x plus 1 times x plus 1, that's, excuse me, a perfect square trinomial, and so what would that factor into?
X cubed.
X squared plus
X squared plus 2x plus 1. It's a perfect square trinomial. And then I would go ahead and multiply these so that you can save some time for yourself. So what do I get when I multiply these together?
X squared. Minus 3x. Or actually, minus 2x.
Yeah, so minus 3x plus x, so minus 2x. And then what? Minus 3. And if you need to write it out in like the separate pieces, that's totally fine. But you can just shorten it out. So then now I can just superfoil essentially what I have. And so I'm going to get x to the 4th minus 2x cubed minus 3x squared plus 2x cubed minus 4x squared minus 6x plus x squared minus 2x minus 3. Combine like terms, but I'm going to cancel some stuff first that I can. So this negative 2x cubed and plus 2x cubed cancel. I don't think anything else cancels completely, so I'll have x to the 4th. X cubed terms are all gone. X squared terms, that's going to give me a negative 6x squared minus 2x minus 3. Wait a second.
It's minus 8x.
So where is there an issue? Because that would be negative 7x squared. Oh wait, I'm looking at the wrong term. But the just, oh, I just missed a term altogether. That's why. Okay. Looks like something's not right. Okay. All right, so that would be your answer to that one, and that makes sense. I had a multiplicity of 3, multiplicity of 1. So it being a function to the 4th power makes sense. Number 16, so same instructions, but I want to do this one just because it's a little different. I've got a 0 at -1 with a multiplicity of 2. And then I've got -2 minus I with a multiplicity of 1.
Do you use some tissues?
All right, what do I know about this problem? Or what's different with this one?
It has imaginary numbers.
Has imaginary numbers. So I have a complex conjugate zero theorem or something like that is what it's called. Yep. So if I have -2 minus I, what else must I also have?
-2 plus I.
Yep, -2 plus I. Since that has a multiplicity of 1, this should also be a multiplicity of 1. So now when I set this one up, what is it going to look like when I've set it up?
X plus 1. X plus 1.
Yeah, either way.
And then
X minus 2 minus
plus 2. And then x plus 2.
So you got to remember each of these things are x equals this, so to move them over, I've got to change their signs. So then this is a perfect square trinomial right here. What does that factor into?
X squared plus 2x plus 1.
And then over here, I'm going to have x squared plus 2x minus xi plus 2x plus 4 minus 2i wait. X squared plus 2x minus xi minus 2i. Okay. Minus xi minus 2i plus I squared. Kind of smushed there. Let's see.
On the first, x plus 2 minus I, how come you wouldn't change the I to a plus?
It was.
Oh my god.
Somebody gave me some false information.
Wow. I didn't say
Is that the strap? Just totally yeah.
I'm being nice because I didn't catch it, but normally I will not give you a point for that if you give me false information. Okay, so that stuff should still be right. So then this is plus xi plus 2i and minus I squared. Okay. So now minus xi plus xi minus 2i plus 2i minus I squared becomes, so then I've got x squared plus 2x plus 1 times x squared plus 4x plus 5 so then multiplying this, I've got x to the 4th plus 4x cubed plus 5x squared plus 2x cubed plus 8x squared plus 10x plus x squared plus 4x plus 5. So then combine like terms, I've got x to the 4th plus 6x cubed plus 14x squared plus 14x plus 5. Is that what y'all got? Alright, that's like a good like halfway stopping point. So I'm going to give you problems to do up to where we are currently. And then tomorrow we'll finish the section up. So problems. 3, 7, 11, 13, and 15. So that'll be up to where we are right now, and then we'll be doing some more with finding zeros and figuring out which ones are and are not zeros and all of that tomorrow to wrap up the section.